section 7.1 is called completing the square, which is a skill you learned in Algebra 1, okay? Completing the square starts with quadratics, okay? Because solving the quadratic is the last part of completing the square. So once you realize the value of solving a quadratic, then you're introduced to completing the square, and the main part of completing the square is getting your trinomial into a perfect binomial, okay? Like x minus 3 times x minus 3, which is x minus 3 quantity squared, okay? All right, so this one, we're going to take it, and because it's set equal to 0, we want to solve for the x. So you're going to do inverse operations until you get the x by itself. So the inverse operation of squaring is square rooting. So you square root both sides. That means that the square root and the square cancel each other out, and you're left with x minus 3 on the left. Okay? On the right, you're going to have the square root of 7, which can you simplify the square root of 7? No. But if it was the square root of 20, you could simplify it. Okay? So sometimes they're simplifiable, and sometimes they're not. Okay? So for these type of problems, you need two answers. So this is where you get plus or minus the square root of 7. Okay? The last step, you want to get that x by itself, is to add 3 to both sides. And so when you write your final answer, you just say 3, write the real number first, plus or minus the square root of 7. And I prefer the answer to be written like this. It's much faster and easier. But this is actually two answers. It's 3 plus the square root of 7 and 3 minus the square root of 7. You just need to know that in your head. That's two answers because it's a quadratic, has an exponent of 2, so you need two answers. Okay? Any questions on example number 1? Okay. These are pretty easy, but I'm going to show you two more because they get a little more complicated, all right? So start example 2 the same way. Take the square root of both sides. Square root and squaring cancel each other out, and you're left with 2x minus 3. And that's equal to plus or minus the square root of 3, which is prime, so it can't be simplified. Okay? Then we're going to add 3 to both sides. So we get 2x equals 3 plus or minus the square root of 3. And then we need to do one more step to get that variable x by itself. So we're going to divide both sides by 2. And so the final answer is x is equal to 3 plus or minus the square root of 3 all over 2. If you want to write it separately, go for it, but I prefer it like this. Okay? So you can see how this one's slightly more complicated than that one. It's introducing fractions, okay? Example number 3 is going to be even a little more complicated. Why? Because this number is negative 4, okay? So watch what happens. When we take the square root of both sides, the inverse operations cancel each other out, and we get x plus 5. And then, when we go to take the square root of negative 4, if you were in Algebra 1, you stop and you said no real solution, right? But we know that the square root of negative 4 is what? 2i. So we say plus or minus 2i. Okay? Last step, subtract 5 from both sides. And so your answer is x is equal to negative 5 plus or minus 2i. Okay? So those are 3 good answers, or 3 good examples for solving quadratics, getting like easy, medium, hard. Okay? So once you can get, if you can get an equation into a binomial perfectly squared, you can see it's relatively easy to solve from there, okay? So what if you're given an equation that's not a perfect square trinomial? So we're going to learn how to deal with that, okay? So this section is called completing the square, okay? Completing the square is where you take your trinomial and you have some coefficient A, some coefficient B, some coefficient C. And so they're going to be numbers there, right? Once you have your numbers A, B, and C, it helps to write them down. You're gonna find a new C. And the way to do that is you're gonna take the B, divide it by 2A, and then square it. That's gonna give you this magic number, right? Does anybody recognize B over 2A from anything? What's that in? It's part of the quadratic formula, okay? All right, so let's look at example number 4. All right. So example number 4, we start with x squared minus 6x minus 3. So when you first look at it, that's not a perfect trinomial, right? Because you can't just say, okay, what would multiply to get -3, but add or subtract to get -6. If you could do that, you would solve it by putting a binomial times a binomial and figure out what x is and figure out what x is, okay? So what you're going to do is you're going to add 3 to both sides. And then you're going to find this number that goes right here, okay? We're going to call it our C, our new C, okay? So in this case, there's a number out in front of the x squared that you can't see. It's a 1, so A is 1. Then there's a number in front of the x. It's -6. Okay, so you're going to take that number, -6, and divide it by 2a. So 2 times 1 is 2, and then we're going to square it. So we have -6 divided by 2, which is -3. And when you square -3, you get +9. Okay, so this is kind of like your side work. Okay, some of you will get good at that and you can do it in your head. Basically, you want to come up with this number 9. So we add 9 right here, which is going to make this a perfect trinomial. Okay, but if we add 9 here, we have to add 9 here. Okay, now that we have this perfect number here, we can write this as a quadratic. So it's going to look like examples 1, 2, and 3. And then from there, we can easily solve it, okay? So what number or what numbers multiply to get 9, but add or subtract to get -6? -3, sorry, -3 and -3. It's the number that we just squared right here. See how we just squared -3? This is the same number. Does that make sense? Okay, they should be the same number every time. All right, what's 3 plus 9? What is it? 12, good, okay. All right, now it looks like examples 1, 2, and 3. Okay, so if you can get to this part, then it's easy. You just take the square root of both sides. That leaves us with x minus 3 on the left. And can we simplify 12? Yes, it does actually have perfect square factors because it's 2 and 6, which is 2 and 3. So the 2 comes out front, the 3 stays inside, so it's plus or minus 2 square roots of 3. Okay? We add 3 to both sides, and then the final answer is x equals 3 plus or minus 2 square roots of 3. All right, so how did I get this number 9? we looked at, hold on.